Hello students, in the lecture number 10, today we will discuss some definitions and some important terms. So this chapter is going to end now. So please concentrate on today's definition. Let us see carefully. It is very easy. Actually it is a descriptive topic. So don't worry about the toughness. Just read the sentences and just show the figures accordingly. That we will conclude with 7 to 8 definitions and 1 or 2 rules which we have already used in examples. Let us check first system of forces. System of forces means what? How the forces are placed in the plane, parallelly, non-parallelly or intersecting, etc, etc. According to that, there are many types of forces exist. Let us check first. It is coplanar forces. What is coplanar forces? So definition says, first of all, when two or more than two forces act on a body, they are called to form a system of forces. Okay, means two or more forces are acting on the body, then they are forming the system of forces. Now, in that system of forces, first one is coplanar forces. You can see in the figure, this is the plane. In the plane, there are three forces acting in the same plane. So, these three forces are acting in the same plane, so they are known as coplanar forces. The forces whose line of action lie in the same plane are known as coplanar forces. Here, forces P1, P2, P3 are coplanar forces. Co means same, planar means along a plane. Okay, so these are the coplanar forces. So first definition is complete, that is coplanar forces. Now second definition is concurrent forces. Okay, so what is concurrent force? The force which meet at one point and known as concurrent forces. The forces which are meeting at the same point are known as concurrent forces. You can check in this figure. At the single point, three forces P1, P2, P3 are meeting. So that's why these three forces are known as concurrent forces. Okay, now the third one is collinear forces. Collinear means in the same line. You just know in the mathematics what is collinear. See this in the figure. This is the straight line. On the same straight line, there are 2 points. First point, second point, and on these points, various forces are acting like this. P1 is going outward, P2 is moving like this or down also, P3 is moving up. Okay, so in the same line, there are many forces are going or acting. So that's why these forces are known as collinear forces. The forces whose line of action lie on the same line are known as collinear forces. You can check in the definition. Okay, let us see the next, number 4, that is coplanar concurrent forces. Read the definition first carefully. The forces which meet at one point and their line of action also lie on the same plane are known as coplanar concurrent forces. Again, the forces which meet at one point and their line of action also lie on the same plane are known as concurrent forces. You can check in the figure. All the forces in the same plane, so that's why they are coplanar forces. Moreover, at the same point, three forces are acting, so they are known as concurrent forces. So that's why this system is known as coplanar concurrent forces. Check next, coplanar non-concurrent forces. First of all, read the definition. We will see the figure on the next page. For this coplanar non-concurrent forces, according to name, coplanar means in the same plane, but non-concurrent means they are not intersecting at any point. Let us see the definition first. The forces whose line of action lie on the same plane, but they do not meet at one point are known as coplanar non-concurrent forces. Okay, it is very clear from the definition itself. Let us see the figure of it. Here it is, the figure. See, in this figure, 1, 2, 3, 4. So at 4 different points, 4 different forces are acting, but not a single force, or not 2 forces, not 3 forces, not 4 forces are intersecting. All are non-intersecting. Means 4 forces are intersecting but at different points, not at the same point if you extend the lines. Okay, so they are not a concurrent forces. Similarly in this, 1, 2, 3, 4. But 4 forces are not intersecting at the same point, so that's why they are non-concurrent forces. But the plane of the forces is same, so they are known as coplanar forces. Okay, now let us see the next non-coplanar concurrent forces. What is non-coplanar? So this is the plane in which a box you can see first, second and third. These three faces means these three planes are different. This is most important figure. These three planes are different like this, 1, 2, 3. But in this, the three forces are acting at corner, are acting at this corner. Okay, so at this corner, forces are intersecting, but from different planes, first, second, third. So these three forces are known as non-coplanar because of different planes, but concurrent because acting at the same point. So that's why this is known as non-coplanar concurrent force system. Let us see the next number 7. Non-coplanar, non-concurrent. Non-coplanar means planes are different. Non-concurrent means points are different. Okay, so check this 3, 1, 2, 3. In these three planes, all the planes are different. So they are known as non-coplanar. Okay, and three forces are also not intersecting. So that's why they are known as non-concurrent. Non-coplanar, non-concurrent force system. Let us check number 8. Like parallel forces. Like parallel forces means what? First of all, read the definition. The forces whose line of action are parallel to each other. Okay, all the forces are parallel to each other like this. And all of them act in the same direction. Okay, direction is also same. Direction is also same. So forces are parallel to each other and direction of there is also same. Then they are known as like parallel forces. But what is unlike parallel forces? In this case, the forces are parallel to each other. But it is not compulsory to have the same direction for all the forces. Then this type of forces are known as unlike parallel forces. Unlike parallel forces. Okay, let's see the next. Number 10, you can check spatial forces. What is spatial forces? Forces acting on the space are known as spatial forces. Mean in the space, random forces are acting, then they are known as spatial forces. Number 11, spatial concurrent forces. Now, spatial means acting in the space, but they are intersecting at one point, meeting at one point. You can see in the parachute like this. The man is hanging on the parachute. 1, 2, 3, 4, 5, etc. forces are acting on the rope, but they are meeting at the person itself. Okay, so they are known as spatial concurrent forces. You can check in the three-dimensional planes. 1, 2, 3, all are meeting at the corner, so they are known as spatial concurrent force system in the Cartesian plane. Next one is spatial non-concurrent forces, like force system. Means spatial means acting in the plane, but non-concurrent means not intersecting. We will check in the next figure. They are non-concurrent, acting in the space but non-concurrent. Let us see. This is the system. In this, there is a building which is having a number of columns. Okay, so this is the plane itself, but one force is acting like this. Load is carrying by the column, load is carried by this column. So number of forces are not intersecting. Okay, see, they are in different direction, like. Okay, so these are known as spatial but non-concurrent force system. Number 13, spatial non-concurrent force unlike force system. Unlike means what? Like means what? They are in the same direction, tensile. Unlike means what? Some are some of the forces are tensile, some of the forces are compressive. So parallel but act in opposite direction. Forces acting on the space, they are parallel also, but act in the opposite direction is known as spatial non-concurrent force but unlike force system. These definitions are also given in your textbook, so don't worry about this. We will solve all the doubts as much as possible. So these are basic definition, and these are also I can tell you this is not much more important from the exam point of view. Already important points we have covered before this lecture. Let us see the next. Now there are two important rules. Now these are most important. First one is that principle of superposition. What is principle of superposition? It states if two equal, opposite and collinear forces, remember equal, opposite and collinear, like this, equal, opposite but collinear. Collinear means equal, opposite, collinear in the same line, intersecting at the point. Means assume Newton's third law, action versus reaction. Okay. Added or removed from the system of forces. Added or removed from the system of forces. Then there will be no change in the system and position of the body. Means if two equal forces are added or removed from the system, then there will be no change in the position of the body. Let us see P1 acting 100 Newton at A. If two equal, opposite and collinear forces, means there are 100 Newton forces, two forces acting at the same point, but they are equal, opposite and collinear forces. Let us see in this figure. Check this. P1 100 Newton, P3 150 Newton, P2 150 Newton, P1 100 Newton. Now actually this is the continuous system. You can see P1 100 Newton in right direction. This P1 100 Newton is also in the right direction. But this 150 Newton, this and this are in opposite direction. So they will balance each other. So there is no effect by this 150 Newton force in the system. It means you are removing the force 150 Newton, then also there will be no effect on the system. That is the principle of superposition. Okay, now check up next principle of transmissibility. This is also most important. Transmissibility means, in the simple language, to convert the tensile force into compressive, or to convert the compressive force into tensile. So this is the last point of today's lecture. Let us see how it acts. In this block, at point A, the force P is compressive. You can convert this force in the tensile force like this. So it will transfer to point B. Simple example is, you are in the home and you are pulling the chair or pulling the table. So you can apply the force from behind the table, then table will move ahead. But second option is that you go in front of the table, and from that front side you just pull the table. So this is the another way, but the table in both the cases moves in the same direction. Okay, so this is the principle of transmissibility of forces. So what is the statement? It states if a force act at any point on a rigid body, it may also be considered to act at any other point on its line of action. If force is act at any one point, then it is also acting on the point B in the same line. Okay, provided the point is rigidly connected with the body, means point A and point B both are rigidly connected with the same body. According to this law, a force acting on a rigid body can be shifted along, according to this law, a force can be shifted along its line of action. A push force can be covered into pull force. A push force can be covered into pull force. Nature of force can be changed. The principle is valid for rigid body only. By shifting the force, only the state of the body remains same, but the internal stresses are definitely changed. Internal stresses may be changed. We will deeply study this point in the upcoming chapters. So don't take it seriously. Just go through it. Just remember the funda of principle of superposition and principle of transmissibility. Rest of the definitions are not much important from the subject point of view. You just concentrate on the remaining chapter. Okay, so in the important topics, we can cover law of parallelogram of forces, its numericals. Lami's theorem is very much important, and some of Lami's theorem, examples of Lami's theorems are also very tough and important. So you just practice them. So that's it for today's lecture. That is lecture number 10. We will meet you soon on Monday with fresh chapter and fresh topics. So hope you are enjoying your study, and this is the YouTube lectures topic 1 series actually completed. So we will meet on Monday with the new chapter. Thank you, students. Goodbye.